Okay, so I'm going to do these review problems, and hopefully you have already tried these and are, or if you're stuck, you're just following along with me. So the first ones are about composition, and basically the idea is it's really just about substitution, and I just want us to see how we can connect um, a function that's written like this to like a normal looking function like that. So So if g of x equals f of 3x plus 6, that's going to be the same as saying if f of x equals 5 to the x, then we're going to write g of x, and maybe I'll use color to highlight these different parts. So g of x equals, well, f of 3x, since f of x is 5 to the x, then f of 3x equals 5 to the 3x, because remember composition is just substitution. So g of x equals 5 to the 3x. And then it's f of 3x plus 6, so plus 6. So that's all you gotta do for that one. All I did was replace f of 3x with 5 to the 3x, and then the plus 6 is just plus 6. So let's do another one. So if g of x equals 4, f of 3x plus 2 minus 1, and f of x equals 1 over x squared plus 2x, then what is g of x in terms of x? So the first thing I'm going to do is write out f of 3x plus 2. And that equals, all I'm doing here, remember, is just substituting 3x plus 2 into my x's here in f of x. So f of 3x plus 2 equals 1 over, I'm going to write it kind of big because I have to put some bigger things in there. I'll go like that in blue, and I'll say we've got 3x plus 2 squared plus 2 times 3x plus 2. And you could expand this. I'm okay with you leaving it like that. But you could expand the bottom so that this equals, let's see, 3x squared, 9x squared plus 12x plus 4. Is that what that would be? Plus 6x plus 4. So then that equals, so this would end up being 1 over 9x squared plus 18x plus 8. So either of these are fine. Okay, number 3, we've got 1/5. Oh, sorry, that's not the full solution. Remember, that's just f of 3x plus 2, and then we have to multiply our final answer by 4, and then subtract 1. So our actual answer is going to be 4. I'll just make this 4 on top because I'm multiplying it by 4, and then at the end I'm subtracting 1. So that's your actual answer. All right, if g of x equals 1/5 times f of 2x plus 5 and f of x equals x cubed, then what is g of x in terms of fx? So first things first, let's find f of 2x plus 5. F of 2x plus 5. Let's do this in red. Equals, well, f of x is x cubed, so f of 2x plus 5 would just be 2x plus 5 parentheses cubed. That is different. This does not equal 2x plus 5 cubed. Can't do that. Got to use parentheses. So f of 2x plus 5 is just 2x plus 5 cubed. And then we're multiplying the whole thing by 1/5. So g of x equals 1/5 of 2x plus 5 cubed. That's our answer. Don't need to expand that. And I don't want to, so I'm not going to. Let's see. Okay, so this one, it looks like it's got all 4 transformations. So let's see. First thing we want to do is find f of 9x plus 8 equals, let's see, f of x is x squared plus 2x. So that means we've got, remember your parentheses again, 9x plus 8 squared plus 2 times 9x plus 8. For the sake of space, I'm not going to expand that. And I specifically wrote that here because I don't want you to do that. It's too much work and it's not really what we're focusing on. I already know you have that skill. So f of 9x plus 8 is equal to this. So then we need to find g of x, which equals 10 times this. Equals 10 times 9x plus 8. Another set of parentheses squared plus, you can expand this, 18x plus 16, probably easier. And then close that one. 10 times that minus 7. So that's your answer. So if you look at it, these vertical transformations happen outside of the function. The minus 7 will be a vertical translation, and the 10 is going to be a vertical stretch. And then the horizontal transformations happen inside the parentheses, right? So that's where we plug in this for x, and it's also when you like add something inside the parentheses, this has both. So the horizontal transformations, the ones that change the x values, happen inside the parentheses. Right here we've got the 9x and the 8. So the 8's going to be horizontal translation. That's going to move it 8 to the left, and then the 9 is going to make it a horizontal squeeze, so it's going to be 9 times smaller. And you can see that stuff in our notes, in the note section on OneNote. So that's those functions. Just like a way to look at how composition relates to like normal functions, because sometimes we only look at it like one way or the other. So a little more composition here. For the following problems, use the following functions. So g of h of x. So g is right here of h of x. So I'm plugging the green function into the red function. So g of h of x is the same as g of 3x plus 2, which equals, remember, use your parentheses, always use your parentheses, 3x plus 2 squared minus 7. So g of h of x is 3x plus 2. We just plug that in for x values in g, and then we're done. H of g of x, so I'll just use the same colors but swap them. So then this is going to be the same as h of g of x is x squared minus 7. So again, I'm just going to plug in x squared minus 7 for all my x values in g of x, in h of x, sorry. So that just equals 3 times x squared minus 7. Whoops. plus 2. That's good. And you could also write this as 3x squared minus 21 plus 2 equals 3x squared minus 19. Also correct. I guess for this one we can do that too. This would be 9x squared plus 12x plus 4 plus 12x plus 4 minus 7. So it would be minus 3. Would be another correct answer if you expanded it. F of s of x. So s of x is this one, f of x. So I guess we'll use different colors for this. Blue. So f of x is x cubed. S of x is x squared minus 6x plus 9. So now we're just going to write, we're going to be looking for f of, and we plug in s of x squared minus 6x plus 9. And then f of x is x cubed, so we're really just taking this function and cubing it. And again, I don't think I would recommend expanding this. So all I did was take this purple function and replace it for the x's in the blue function. And I remembered to use my parentheses because that makes the difference in it being right or wrong. P of g of 4. I think I'm running out of colors. Let's see. So what should I use? Orange and pink. All right. P is pink, and then G is red. So I only need one. All right. So P of G of 4 is the same as, well, first I need to find G of 4. Well, that's equal to, once again, I'm just replacing x with 4. That equals 4 squared minus 7. That's 16 minus 7, which equals 9. So G of 4 equals 9. So then I'm just trying to find P of 9. So P of 9 equals, now I'm just plugging 9 into P. Whoops. Plugging 9 into P. What is P? P is square root of x. So P of 9 equals the square root of 9, and that equals 3. So P of 9 equals 3. That one is pretty straightforward. All right, so now we're using the values in the table for f and g. So we've done this before, but with graphs. Now we're going to do it with table values, just to get a different look at it. So g of 1, that means g when x equals 1. So when x equals 1, g of x equals 2. So g of 1 equals 2, so f of g of 1 is the same as f of 2. Well, when x equals 2, f of x equals 5. Okay, now we're going to do g of 4. Well, g when x equals 4, g of x equals 5. So then g of 4 equals 5. And f of g of 4, this is the same as f of 5, because g of 4 is 5. F of 5 equals, let's see, when x equals 5, f equals 1. So this equals 1. and then f of g 3. So when g equals 3, g of 3 equals, when x equals 3, g equals 7, g of 3 equals 7. So then f of 7 equals, see, when x equals 7, it's not on there, so that means it does not exist. Also known as DNE, or undefined. So that's how you do that one. For each of the following representations, find the domain and range in both interval and set notation. You don't need to write equations for the graphs, and you don't need to draw graphs for the equations below. So let's see. So for the first one, we're trying to find the domain, and we're going to write it in interval notation. So let's see. I'm going to mark the x-axis. So clearly, from here to here and on, so I know it's negative infinity is my lower limit. And that's going to be true on both sides. And since it's negative infinity, it's a parenthesis. And remember the rules about what each notation is all in your note section. So if you forget, which I often do, which is which, just check your notes. So to that point, negative infinity to negative 9, we've got this function here. And then it switches, but it looks like a pretty smooth transition because it's a full circle here to an empty circle here, which means it's going to be continuous in terms of our domain. So our domain continues through the y-axis from here to here. And then once again, we've got a full circle and an empty circle. So our domain is going to be continuous again, and we don't have to change our notation. And then it just goes down to what looks like positive infinity. So then we're good. And then we just need to write, just so you can see it here. So then it's just negative infinity to infinity. So that's our domain. Oh, that's not set notation. Less than or equal to, oops, can't be equal to, it's infinity. Less than x, which is less than infinity. So then for our range, well, we've got an arrow here. Our range kind of taps out in the positive direction, though. You can see, so our lower limit of our range is clearly negative infinity because we've got an arrow on the end, which means it's just going to keep going down forever. And then it's going to go up to here. It looks like we've got this over here, and then this one goes up even higher. So it looks almost like this whole chunk doesn't change our range at all, because I can also get it there. So I'm just going to ignore it while I write my range, because it doesn't actually do anything to the range here. Because now I'm going up with this function, stop here. This is also an empty circle, which means there's going to be a stop here in my range. So this is going to be negative infinity to negative 1, 2, 3. And it's not included. They're both empty circles. And then I'm going to do union, negative infinity, negative 3. And then I start again at negative 3, and it looks like it goes up to 6. And then it doesn't go up any higher. None of this is ever going to be hit by the function, so it's just from here to here. and it restarts at -3. It's just not included. So that means we're going to have another -3, comma 6. So that's our range in interval notation. So this is going to be negative infinity is less than x, which is less than -3, or -3 is less than x, which is less than or equal to 6. Oh, I missed that here. So over here, this should have been a bracket because it was less than or equal to 6. I have a full circle up top. All right, so again, I don't need to write equations for that. I can just do the domain and range. So let's move on to this other graph. The domain here, it's not very clear, but these should be arrows. The domain here, since there are arrows on both ends, it starts at negative infinity. So negative infinity, I'll put that on both of them. And then what happens? The x values goes all the way up to 1. Looks like this is 1 because this is 2. And then if you go up here, it's a full circle to empty circle, so this stays continuous. And then you go over here, you get a full circle to empty circle, that stays continuous. And then it looks like it's just going to keep going because there's then another arrow here. So this is going to be same as our last one. Whoops. And then these are just, this is really bad. There we go. All right, now we're going to do our range. So, well, it looks like in this function, my minimum is going to be 0. So I can just write 0, 0. And then, well, I've got like a break over here between 1 and 2, but I've got this over here that fills that gap. In fact, I've got this whole thing, looks like it goes from 0 up to infinity. So no matter what's happening over here, doesn't matter, because this has a range of 0 to infinity, which satisfies any values above 0. And it looks like it can equal 0, so I'm going to use a bracket here, and then a parenthesis there, and then this is going to be less than or equal to, and this is just going to be less than. So that's it for those two. Now we're looking at it in terms of equations. So these ones you have to be a little more tricky. You could graph it in Desmos and then like base it on the graph if you're more comfortable doing it that way. You know, it's good to know what tools you have and to use them. In this situation, I know, and it even says in our notes on piecewise functions, or is it? I think it's in domain and range actually in page 4, right here. So there are certain equations where the domain is naturally restricted, like you can't take the square root of a negative number, like this. You can't divide by 0. And those look like those are both going to be useful in what we're doing right now, because I see a square root. So that means I need to make sure that I'm not taking the square root of a negative number when I'm figuring out what my domain is, because it's a square root. So what that means, it means that negative 5x plus 25 cannot be negative. It has to be a positive number. So I can even write it as greater than 0. Well, greater than or equal to 0, right? Because if it equals 0, I'm taking the square root of 0, which is 0. That's okay. So negative 5x plus 25 is greater than or equal to 0. So in order to figure out what x equals, I can just treat this like a regular equation and solve it. The only time that it's different is if you divide by a negative number, then you have to flip this guy to the other direction. Otherwise, it's just like doing regular algebra. So I'm going to do minus 25, minus 25. So then you get negative 5x is greater than or equal to negative 25. and then divide by -5. Since I'm dividing by a negative, I have to flip that. So I'm going to get x is less than or equal to 5. And that's my domain. And I can even write that as my set notation. I don't necessarily need to include the infinity. And this makes sense. I can plug in 5 here. If I get plug in 5, it's -5 times 5 is -25. -25 plus 25 is 0. So that'd be the square root of 0. That's okay. If I plug in a number slightly bigger than 5, like 6, -5 times 6 is -30. -30 plus 25 is -5. That's square root of a negative, doesn't work. So that kind of proves to me that this is correct, that I can't have any numbers larger than 5. So that's my set notation. For interval notation, I do need to include my -infinity, comma, 5, and it's less than or equal to, so I do a bracket. And then for the range, that's a little trickier because you have to kind of plug in your domain values to see if there's any spots where you can't go. In terms of a square root function, and we looked at function families briefly early on, but if you remember what a square root graph looks like, it's kind of like this. So immediately I see it starts like right here at 0, and it just kind of tapers off. So basically what we're going to do here to figure out what our range is, that's just square root of x. This is square root of -5x plus 25. But actually the output is a square root, and we're not going to get any negative numbers. So that means it's still just going to be 0. So the graph's going to stretch and move a bit, but like it could be like this. It's plus 25, so it'll be like something like that. And I guess actually it's going the other direction because we got the negative. So it's going to be like that, go in that direction. But still, it's stuck there on that y-axis. So my range is still going to be, you see, I can have 0. So I'm going to do, including it, 0 is less than or equal to infinity. And then 0, or I'm going to say y is greater than or equal to 0. And that works. Let's see. Another way to do that, because I kind of just did it using the graph, and maybe that's not something you're as comfortable with, you can think about transformations, like we had talked about on some earlier problems. If this was a transformation of y equals the square root of x, which we know the domain is 0 to infinity, we would be making 2 transformations inside the parentheses. So like, because this would be the -5 is like f of -5 x plus 25. So that's what that would look like. So this would be a horizontal dilation, and this would be a horizontal translation. So you're doing two transformations that affect the x values but not the y. So regardless, the y values are going to be staying the same from that parent function, y equals square root of x. Okay, looking at this one, remember when I looked at the notes, I saw that I can't divide by 0. That's another one of those rules that's going to have domain restrictions. So in this situation, I can't divide by 0. So that means that x plus 2 does not equal 0. Now, in this situation, I can divide by a negative and I can divide by a positive, just not 0. So that means x can be anything except for that one value that makes this 0, which I don't need to do the algebra. -2 plus 2 equals 0. So that means x does not equal -2. And you can use that for your set notation. And then let's see, so our domain, yeah, those are our only x values we can't have. So that means we're going to write this in interval notation as negative infinity, comma, -2, not included, union, -2, comma, infinity, neither included. All right, and then for our range, all the possible y values. So again, this is something that you graphing it could be really helpful because you would see, and what you would get if you graphed it is you would get a hyperbola. So, it would be like one of these, except in this case, you've got a couple transformations. The x value moves it 2 to the left. So it's going to be like, and then it's up 3. So it's going to be like that. And then something like that. That's what the graph would look like. And what's happening is we've got asymptotes here and here, and those tell us about our domain. Those asymptotes tell us that we can't have those values. So that gives me one x value and one y value that are not possible to achieve. I already found the x value. In fact, I know that this right here, the vertical asymptote, this one, is x equals -2, because we already figured that out. So now I need to figure out what that y asymptote is. Well, what it means is it's a y value I'm never going to get, right? So looking at this function, and this is true for all rational functions, it's a good thing to remember, kind of like you can't divide by 0. You also can't have something where you have 1 over x plus anything really equal to 0. It'll never happen because this is a fraction, because I have that 1 on top. This is a fraction, and no matter what I make x, I can't make this equal to 0. There's nothing you can divide something by that makes it equal to 0. So that means this is going to be some quantity greater than 0, either positive or negative. So that means that the first part of this function, 1 over x plus 2 does not equal 0. Well, that means that f of x can never equal 3, because this will never equal 0 plus 3. So that means my y value that I can't get is 3. And if you think about it, this would be like that first hyperbola I drew where both of your asymptotes are at 0, which would be like 1 over x, and you'd have like that and that. What happened is I just did a transformation up 3. So I moved this asymptote that's normally at 0, and I moved it up here to 3, to y equals 3. So that means that for my set notation, I'm just going to say y does not equal 3, and then I'm going to do the same thing here. Negative infinity is less than 3. Union 3 is less than, and negative infinity is less than 3, but that's not how that's read. Negative infinity to 3, union 3 to infinity. And those are your answers for those ones. And then we've just got some piecewise stuff. So graph the following piecewise equation. So let's see. X minus 1 squared, that is a parabola from 1. Basically, this just tells me I'm transforming it left 1. So my vertex is going to be like right there. And then it's from -5 to 1. So -5 to +1. And then otherwise it's a normal parabola. So that means up 1 over 1, up 1 over 1, over 2, up 4, over 2, up 4. And then it's going to stop here. This is less than and not less than or equal to. You can see right there. So that's going to be an open circle. And then on this side, it's going to be a closed circle because it's less than or equal to. So that means, but what does that happen at? That happens at -5. So that's going to be like up at 16. We're not even going to see that actually. It's going to be like, it'll be somewhere up here. But we're going to draw this. And then we've got 2x from x is greater than 1, so that means it's just going to be a straight line from here with up 1 over 2. I'll do blue, so 2x, and then it's greater than or equal to 1, so starting here, and then I'm just going to graph this line and then start drawing it when I get to this point here. So up, so over 1, up 2, over 1, up 2, over, and so that, I guess it starts here, over 1, up 2, because y equals 2x. So if x equals 1, y equals 2. And that's where it starts. You can also just plug this number into the equation. So if it's 2x, you just plug in 1, and then you get y equals 2. And that's where you start. So that's right here. And then you just draw that line with the slope of 2, up 2 over 1, up 2 over 1, and it goes on because there's no upper bound. So that's your graph. Let's see, for 9, we want to write the equation. And so we're going to have to write two equations in two domains. So first off, I can see that it's basically my domain here is going to be negative infinity is going to be my minimum. So I'm just going to say when x is less than -1. So I'm going to write that right away for x less than, and not less than or equal to, just less than -1. And then my second one is going to be from -1 is less than or equal to, because I got a full circle, x, which is less than or equal to 3 because of here. And then this is -1. So that's how I know those domains. So now I need to write equations for each of those. This first line, it is a positive slope. Let's see if I can find some good points. This one is right on a point, and this one's right on a intersection, so I'm going to use that as my slope. Let's see, 1, 2, 3, over 3, up 1. So my rise over run, so it's going to be 1/3 is going to be my slope. So we're going to get f of x equals, and then we'll do a big bracket. And then we'll say y equal, it would be like 1/3 x, and then what's the intercept? It's going to be right at 2, because it's every 3 it crosses a point. So it's going to be 1/3 x plus 2. This is my intercept. It's not actually ever getting there, but that's how I know where to put the line vertically. Okay, so for my second line, first thing I see, it's a negative slope because it slants downward. And that my y-intercept is also at 2. So I'm just going to put a plus 2 here, and now I just need to figure out what my slope is. Well, it's going to be over 1 up 2, so it's -2. -2x plus 2. So that's your answer. And then let's see, last two. So our piecewise equation, let's see, our first one is x squared minus 1. So that's going to be a vertical transformation on a parabola, and I'm just moving it down 1. So that means we're going to go up 1 over 1. It's a regular parabola. It's not stretched or squeezed. Up 2 over 1, up 3. Over 2, up 3. Over 3, up 9. And so on. So this is from -infinity to 3. So here's 3. We get an arrow here, so we know it goes on to infinity. This is going to be a closed circle. Whoops. Or an open circle because of here. So then for x is greater than or equal to 3, it's just 3x minus 2. So I'm going to start here with my y-intercept and then just say 3x minus 2. So my slope is 3, so it's going to be over 1 up 3. So that's point, but that's not going to be on our line. Over 1 up 3. Still not there. Over 1 up 1, 2, 3. So it's got like a sort of intersection there. And then it's going to be 3x is my slope, so over 1 up 3 again, and then it goes on. Interesting thing, I just realized that's not a function because it doesn't pass the vertical line test. Then there's that intersection of the blue line with the red line. But that's fine. Write the equation for the graph below. So now we got to do we got 3 functions it's going to be, so there's 3 chunks here. So our first one is going to be from -infinity to -3, so this is just going to be x is less than or equal to -3 because of the open circle, we have less than or equal to. And then the next one is going to be from -3 to 0. Neither of those are included, so it's less than x, less than 0. And then the last one is from 0 to infinity, so we can just say x is greater than or equal to 0. So for the first one, it's just y equals -2, right? So then I can just write -2 because it's a flat line. And then the second one, my slope is, let's see, down 2 over 2, it's just -1. So this is going to be -x. And then my y-intercept is 4 because you can see where it crosses, -x plus 4. And then my second line, well, this is just over 1, up 1, goes through 0. That's just y equals x. So then we just write x. And that's it for that. Good luck on the quiz. Let me know if you have any questions. Come to office hours. And I'll see you in 2 minutes.